Hey everyone, in this video I'll show you how to make a custom inventory. Make sure you watch to the end so you don't miss a thing. If you want the files for this, head over to my Patreon. Members also get access to an exclusive channel in the Discord server where you can send your video ideas. I'll be looking at these video ideas first, so if you want me to make a video idea soon, this is perfect for you. In the replicated storage, create a folder. Name it Custom Inventory. Inside, create another folder. Name it Settings. To organize the player's inventories, we'll have a single folder for the inventory. Inside will be two folders, one for the hotbar tools and another for the backpack tools. In each folder will be object values pointing to the actual tool objects. For each folder, let's create a string value for its name inside the settings folder. This will prevent us from making mistakes, such as writing the folder's name incorrectly. The first value is called backpack folder name. Set its value to whatever you want the backpack folder to be called. The second value is called hotbar folder name. Set its value to whatever you want the hotbar folder to be called. The last is called inventory folder name. Set its value to whatever you want the inventory folder to be called. Since it will be directly parented to the player, its name should not match anything else found in the player. Now let's create an int value. Name it num hotbar slots. Its value tells us how many tools can be stored on the hotbar. Then create a number value. Name it drop tool distance. Its value is how far tools should be placed in front of the player when they're dropped. I'll go with 15, but we can change it later if we need to. Create a module script. Name it backpack keybinds. Inside the script, create a dictionary named Keybinds. This will map a slot number to a list. Inside the list will be all the possible inputs that can be used to equip or unequip the tool at that slot. In this case, the first slot in the backpack, which is the 6th slot after considering the hotbar slots, will be activated using the number 6 key on the keyboard. You can add as many inputs to the list as you want, so you can support other forms of input, such as a controller. You don't need to add inputs for every slot. In this case, only the first 5 slots in the backpack have inputs. Now make another dictionary named Keybind displays. This time, we're mapping the slot number to a string. This string is the text displayed in the GUI as the hotkey label. So rather than displaying the word 6, the number 6 will be displayed. For the X, C and V slots, we can just use the keycode labels. And at the end, we'll return both dictionaries. We need to put them in a list since module scripts can only return one thing. Let's copy the script and rename it to hotbar keybinds. The script will apply to the hotbar instead. Let's change the inputs to the number keys 1 to 5. Then we need to add mappings to the Keybind displays dictionary. Make one more module script. Name it other keybinds. Make a dictionary. Inside, we'll have one mapping from open inventory to a list of inputs. This list contains the inputs we can use to open and close the backpack. Let's use the backquote key, which is the key used in the default Roblox backpack. Finally, return the dictionary. Now head over to the server script service, create a folder, again named custom inventory, to keep everything organized. Inside, create a script. Let's first get the folder in the replicated storage. We'll need all the values inside the folder. Create a function called createInventoryFolder. It will receive a player and will create the inventory folders for them. First, create the inventory folder and set its name. Then create the hotbar folder and set its name. Parent it to the inventory folder. We then need to create the object values for the hotbar. Let's use a for loop that goes from 1 to the number of hotbar slots. Each iteration will make a new object value. Set its name to the iterator. Finally, parent it to the hotbar folder. Now create the backpack folder and set its name. Parent it to the inventory folder. We won't create any values inside it. This is because the backpack has a variable size, so we'll create and remove values when tools are added or removed. Now parent the inventory folder to the player. Create a function called onPlayerAdded that receives a player. This function will respond to whenever a player joins. Inside, we'll create the inventory folder for the player using the function we just wrote. Now we'll bind the function to the onPlayerAdded event of the player's service. Let's run the game to make sure everything is working. Open the player and you should see the folders. The hotbar folder should have object values named numerically. Now we need to handle when tools are added or removed. Adding could mean the player picks up a tool by walking over it. Removing could mean the player drops a tool by pressing backspace. When this happens, we want to get a list of the player's tools. This includes the tools in the backpack folder that is generated by Roblox and the tool they have equipped. Then we need to go through all the values in the inventory folder, including the hotbar and backpack values. For each value, we'll look up the tool in the list. If we can't find the tool in the list, it has been removed. Once a tool is removed, the value referencing it will be set to null, and if it's a backpack value, it will be deleted. This means we'll shift down every value starting from the value referencing the removed tool. Then we'll delete the value at the very end, which will be empty as we've shifted its value down to the previous object value. We also need to go through all the tools in the list and find ones that don't have an object value yet. This means a tool has been added. For added tools, we'll first look inside the hotbar folder to see if any slots are free. Otherwise, we'll add a new value to the end of the backpack folder. Create a function called getTools. It will take the backpack folder generated by Roblox and the character of a player. The list tools will contain all the tools a player has. First, we'll get the tools in the backpack using getChildren. To check if a tool's equipped, we need to look for an object inside the character of the type tool. To do this, we used findFirstChildOfClass. If no tool is inside the character, nil is returned, so we'll make sure the variable is not equal to nil before adding it to the list. Finally, return the list. Now we need a function to find an object value from a tool. Create a function named findValueFromTool. It will take the two inventory folders and the tool to look for. We'll go through every value in the hotbar folder. If there's a match, we'll return that value. Then we'll do the same for the backpack folder. Create a function called addNewBackpackValue. This takes the backpack folder and a tool. It will create a new object value at the end of the backpack folder. First, we need the number of existing backpack values. This is done by getting the length of the list returned by getChildren. Now let's create a new object value. Set its name to the number of values plus 1. Set its value to the tool. Finally, parent it to the backpack. We also need a function to find the first available slot in the hotbar, so create a function named findFreeHotbarSlot. It'll take the hotbar folder. We'll iterate from 1 to the number of hotbar slots. We don't want to iterate over the list returned by getChildren because we want to find the first free slot, not just a randomly chosen free slot. Inside, we'll check if the value of the slot is empty. If so, we'll immediately return that slot value. For example, if slots 2, 3 and 5 are empty, the for loop will first check slot 1. It will see that the value is occupied and move on to slot 2. It will notice slot 2 is empty and return it. Since we've returned, the for loop ends here, so any further slots aren't considered. Create a function called shiftBackpackValuesDown. It will take the backpack folder and the value in the backpack folder to start at. The function will move every backpack value after the starting inventory value down by 1, essentially deleting that value. We'll start by creating an iterator variable. It'll begin at a number 1 greater than the number of the given backpack value. Then we'll use a while loop that will check if a value exists in the backpack with that number. If it doesn't, we've reached the end of the backpack. Inside the loop, we'll set the value at the number 1 less than the iterator to the value at the iterator. We'll then increment the iterator by 1. After the loop, there will be a value at the end that is empty. We can delete that value, which will have a number 1 less than the iterator. Now create a function called updatePlayerTools that takes a player. It will make use of the functions we just wrote to update the backpack and hotbar folders of the player. Start by getting the list of the player's tools. Then we need the hotbar and backpack folders. We'll make a list that contains all the values in the backpack folder. Then add the values in the hotbar folder to the list. Now we can go through each value and check if it's inside the player's list of tools. If not, the tool was removed. Set the value to nil. If the value is inside the backpack folder, we'll need to delete it. We'll use the shift backpack values down function. Next, we need to go through every tool in the player's list of tools. Use the find value from tool function to check if a value references the tool. If not, we'll first try to find a free slot in the hotbar. If there is one, set its value to the tool. Otherwise, add the tool to the end of the backpack folder. We'll also need a function to reset all the values. It'll be used each time the character spawns in. This is because the player won't necessarily have the same tools as before. For example, the default behavior upon respawning is that you lose all of your tools. First, let's get the inventory folders. Go through each value in the hotbar folder and set them to null. Then we can delete all the values in the backpack folder. Now create a function called trackPlayerTools. This is the function that will actually detect when something is added or removed. Inside, create a local function called updateThisPlayerTools. It'll simply call the updatePlayerTools function, passing the player to it. Now let's call this function. This will set up all the values initially, which may be needed if the character has already spawned in by the time this function runs. Then we'll use the character added event of the player to respond to whenever the character spawns in. First, we'll clear all the values, then we'll call updateThisPlayerTools to set the values. To detect when new tools are added or existing tools are removed, we'll use the child added and child removed events. We'll first use them on the player's backpack, which is where their unequipped tools are stored. We need to do this inside the character added event because a new backpack is created each time the character spawns. Then we'll use the events on the character. Now we need to call this function in response to the player added event. That's everything we need to do for now, but before we can test, we need to add some tools to the game. Put some in starter pack so we spawn in with some tools, and some in the workspace so we can pick up some tools later. Now let's run the game. Open up the inventory folder. Since we have 4 tools, we should have the first 4 hotbar values occupied and the 5th one empty. As soon as we pick up another tool, the 5th hotbar value is updated. Now if we drop the first tool, the first value should become empty. If we pick up a tool, the first value is updated. We also picked up another tool. In the backpack folder, a new value has been created for that tool. As we pick up more tools, we get more values in the backpack. If we drop the 6th tool, which is the first value in the backpack, all the values will shift down, so we'll only have 11 values in the backpack. If we drop the 10th tool in the backpack, only the 11th will shift down. Now create another folder in the custom inventory folder in the replicated storage, name it remote events. Before we create any remote events, let's take a look at all the requests a client can make. They can drop the tool, equip a tool, unequip a tool, swap the values of 2 slots, and move an existing value to the end of the backpack folder. Create a remote event for each of these. Head over to the script and create references to each remote event. We'll start with unequipping a tool, create a function called Unequip tool. It will receive the player. First, we'll get their character. If it doesn't exist, we can just return. Then we'll look for a tool inside the character. If we can't find one, again, we can just return. Finally, we can parent the tool to the player's backpack. Now we need to bind this function to the onServer event of the Unequip tool remote event. Let's test the game. We'll use the command bar to test the remote events. All we have to do for the Unequip tool remote event is fire it. Now we'll handle equipping a tool. Create a function called equip tool, which will receive a tool alongside the player. First we'll get the character. We need to call Unequip tool in case the player already has a tool equipped. Finally, parent the tool to the character. Now let's respond to the equip tool remote event. This time we'll create a separate function. Inside we'll make sure the player's character has spawned in. If not, return. Then we can call the equip tool function. But before we do that, we also need to validate the tool parameter. This is because a cheater could send a tool that doesn't belong to them, allowing the cheater to steal another player's tool or to get a tool they haven't unlocked yet. Make a function called validateToolParameter that takes a player and a tool. First, we'll do type checks. Make sure the tool is an instance type, and a specific type of instance is a tool. Then make sure the tool is either parented to the player's backpack or character. If all these conditions are met, we can return true. Now we can call this function before equipping the tool. Let's run the game. We'll use the command bar. Make sure you're using the equip tool remote event. We also need to give a tool. Now let's try to equip a tool while we already have a tool equipped. It swaps the tool as expected. Now we'll handle dropping a tool. Create a function called drop tool. It will also receive the player and tool. We'll need the inventory folders. Then we need to find the value associated with the tool. If the value is in the backpack folder, we need to shift down all the values in front of it. If it's in the hotbar folder, we just need to set the value to null. Now we need the character and their humanoid root part. Then get the humanoid root part C-frame. The offset will use the C-frame's look vector, which is the direction the player is facing. Multiply it by a vector of 1, 0, 1. This will remove the Y component, so the offset is completely horizontal. Finally, multiply by the drop tool distance. Now we can add the humanoid root part C-frame and the offset we just calculated. Parent the tool to the workspace. Then set its handle C-frame to the C-frame we calculated. This will require your tools to have a part called handle, which everything else is attached to. If your tools don't have the handle part, you'll need to change this line of code. Now let's respond to the drop tool remote event. Again, we'll make a separate function. Validate the tool parameter. Then we can call drop tool. Let's test the game. Make sure you change the remote event to drop tool in the command bar. Let's also try dropping a tool we have equipped. Now let's handle swapping values. Create a function called swap slots. It will receive the player and the two values to swap. First, we'll store the first value in a temporary variable. Then we can move the second value to the first. Finally, set the second value to the temporary variable. Now we need the backpack folder. If the first slot is in the backpack folder and its value is empty, we need to shift down all the backpack values in front of it. Otherwise, we'll do the same check on the second slot. We'll respond to the swap slots remote event with a separate function. First, make sure the two values are not the same because you can't swap a slot with itself. Then we can call the swap slots function. Like we did with the tool parameter, we need to validate the slot parameters. Let's make a function called validate slot that takes a player and a slot value. First we'll do type checks. Now let's get the inventory folders. A slot will only be valid if it belongs to one of these folders, so we'll return that condition. Back in the on-server event, we can validate both slots. Now let's run the game. Change the remote event to swap slots. Then we can create a reference to the player's hotbar folder. Now let's try swapping 2 hotbar slots. And there seems to be an error. It's just a typo. Now everything should be fine. Once we run the code, the tools referenced in the values are swapped. Let's pick up some more tools to fill up the backpack folder. Now we need a reference to the backpack folder. Let's try swapping a backpack value with a hotbar value. Drop one of the hotbar tools to make the value empty. Now we can test swapping an empty value with a backpack value. The backpack value gets deleted since it became empty, and the values in front are shifted down. The last thing we need to handle is moving values to the end of the backpack. Create a function called moveToEndOfBackpack that takes a player and a value. We'll need the backpack folder. Then use the addNewBackpack value function to create a new value at the end of the backpack. We'll give the value held in the slot as the tool, then set the value of the slot to nil. Now we need to check if the slot is in the backpack folder. If it is, we need to shift down all the values in front. Respond to the moveToEndOfBackpack remote event with a separate function. First validate the slot. Also make sure the slot has a value. If it doesn't, we shouldn't be able to move it to the end of the backpack. Finally, use the moveToEndOfBackpack function. Make sure you're using the moveToEndOfBackpack remote event. Then we just need to pass a single value. Let's try moving a hotbar value to the end of the backpack folder. We can also try moving a backpack value to the end of the backpack folder. Now we're done with the server side. In the starter GUI, create a folder called CUSTOM INVENTORY. Inside, create a screen GUI. Inside that, create a frame called hotbar container. Position it where you want the hotbar. Since we have 5 slots in the hotbar, we want a 5:1 width to height ratio. So I'll go with a size of 500 by 100. We should also add a UI aspect ratio constraint so the ratio doesn't change with different resolutions. Inside, create another frame. Name it slots container. This is what will contain the actual slots. I'll set its size to 1010 so it fills the entire hotbar container frame. Now create a UI list layout inside the frame. We'll use this to automatically position the slots. Set the fill direction to horizontal. We can also set the horizontal alignment to center. We also need to set the sort order to name. This is so we can specify the order slots are displayed. We'll be naming the slots such that they get ordered numerically. Inside the hotbar container frame, create any kind of button. Name it Open Backpack Button. It will open and close the backpack when we click on it. Let's change the colors to make it look nicer. In the screen GUI, create another frame. Name it Backpack Container. This will contain the backpack slots. We should keep its width consistent with the hotbar. For the height, we want a multiple of the hotbar, so I'll go with 300, so the backpack will fit 3 rows of slots. Again, we should add a UI aspect ratio constraint. Inside, create a scrolling frame. Name it Backpack Scroller. Let's set its size to 1010 so it fills the backpack container frame. Then set its automatic canvas size to Y. This means the scrolling frame will automatically change its canvas height to fit all the contents inside. Set the canvas size to 0000 as it doesn't have any contents right now. We can also set the scrolling direction to Y. Inside the scrolling frame, create a UI grid layout. Similar to the UI list layout, it will automatically position the slots for us. Instead of placing all the slots in a single row, it will place the slots in a grid. I'll set the cell padding to 0 on everything. For the cell size, I want a 5x3 grid, so the X scale will be 0.2 and the Y scale will be 0.3 recurring. Inside the backpack container frame, create a button, name it Close Backpack Button. When we click on it, the backpack will close. Let's also change the colors for the backpack. And we also need to set the sort order for the UI grid layout to name. Inside the slots container frame, create a button. Name it Slot Button. This will display a single slot value. I'll set its size to 100 by 100. Since I'm using a text button, I'll set its text to nothing. In the slot button, create a viewport frame. This will contain the 3D view of the tool. Now create an image label. Name it Texture ID Image. This will display the Texture ID property of the tool. The Texture ID will take priority. If the tool doesn't have one, the viewport frame will be used instead. Create a text label named Hotkey Label. This will display the key used to unequip or equip that tool. I'll set the X alignment to right because the hotkey label will be in the top right. If the input key for this slot is 5, then the number 5 should show up. I'll also set the background transparency to 1 so the background is hidden. Create another text label. Name this one Tool Name Label. This will display the name of the tool. I'll position it at the bottom of the button. Let's also set its background transparency to 1. Do the same for the other components. Let's duplicate the slot button a couple times. Also put some in the backpack scroller. Make sure the scrolling frame changes size properly when there's more slots than can fit at one time. Once you've confirmed everything is fine, delete all the duplicates. In the replicated storage, create a folder called GUIs. To keep everything organized, create another folder that will contain the slot button. Name it Inventory Slot. Now we can drag the slot button into this folder. In the Starter GUIs Custom Inventory folder, create a local script. First, we'll get the Starter GUI service. Use its set core GUI enabled function. This allows us to hide the default Roblox UI. In this case, we want to hide the default backpack UI, and to hide it, we simply give false. Once we run the game, we shouldn't see the default backpack UI anymore. Now let's get the folder in the replicated storage. We need the remote events, so we can copy the code from the server script. We also need the settings values, so we can copy that too. The local script won't need the drop tool distance, so we can remove that line. Now we need to get the Keybind module scripts. We're using unpack, which will split the two returned items across the two variables we created here. Now do the same for the backpack Keybinds module script. The last module script only returns one thing, so we don't need to unpack it. Next, we need to get the slot button template. We also need the player and the character. From the player we can get the inventory folders. Finally, we need the GUI components. For the backpack container, we should set visible to false, which will initially hide it. The first thing we'll do is handle opening and closing the backpack. Create a function called openBackpack, which we'll use to open the backpack. Inside, we'll simply set the visibility of the backpack container to true. Next, we need a function called closeBackpack. This time, we'll set the visibility to false. Now create a function called toggleBackpack. This will toggle the visibility of the backpack. First, check the current visibility of the backpack. If it's visible, call the closeBackpack function, otherwise call the openBackpack function. We'll use the mouse button one-click event to detect when the close button is clicked. When it's clicked, we'll call closeBackpack. For the open button, we'll call toggleBackpack, so the open button can also be used to close the backpack. Let's test the game to make sure everything is working fine. We'll need the context action service to respond to user inputs. The toggle backpack function can now receive some parameters. These are parameters passed from the context action service. In the function, we'll check if the input state parameter has been passed. If not, it means the function was called from pressing one of the buttons and we can just continue. Otherwise, it means the function was called by the context action service. Then, if the input state is anything other than begin, we'll return. This is because the context action service will call this function during any state of the key press. This includes when the key is released. We only want to respond when the key is pressed down initially. Now we'll use the bind action method of the context action service. The first argument is the action name. We can choose anything as long as it's unique from any other action name we create. The second argument is the function to call. We want to call the toggle backpack function. Then we'll give false, meaning a touch button for mobile devices won't be created. Finally, we can pass as many arguments as we want for whatever inputs should trigger the toggle backpack function. The inputs were defined in the other Keybinds module script. We need to unpack the list returned by the module scripts, which will split all the inputs in the list as separate arguments. Now let's test the game to make sure it works. Now we'll handle creating the slot buttons. First, we need a function to hide a slot button when the associated value is empty. This function will receive a slot button. We'll set the visibility of the viewport frame to false. Do the same for the texture ID image. And also for the tool name label. You can also do the same for the hotkey label if you want. I've chosen not to, which means the hotkey label will stay visible even when a tool isn't available. Now we need a function to make a slot button visible again. This will also receive a slot button. First, we'll check if the texture ID image displays an image. If it does, we'll make it visible. And we'll also hide the viewport frame. Otherwise, we'll do the opposite. Finally, we'll also make the tool name label visible. Next, create a function called setUpViewportFrame. This will take a slot button and a tool and set up the viewport frame. First, make a model to contain the tool's parts. Then, we need a copy of the tool. Go through all the descendants of the tool. If the descendant is a local script, or sound, delete the descendant. This will remove any objects that could cause unexpected behavior. Then we'll go through all the children in the tool. For each child, we'll move it to the model. Then we can delete the leftover tool. To determine the position of the camera relative to the model, we'll need the model's size. We'll do this using the getBoundingBox method, which will also return the C-frame of the model. Then we'll create a new part. Set its transparency to 1 so it's invisible. Then set its C-frame to the model's C-frame. Finally, parent it to the model. We'll use this part as the primary part of the model, allowing us to pivot the entire model around this one part. Now we can just set the C-frame of the whole model to a blank C-frame, placing it at the origin. Create the camera for the viewport frame. Now we'll calculate the distance between the camera and model. For now, we'll use the Y height of the model, but we can adjust this later. Then we can set the C frame of the camera. Since the model is at the origin, we can use the Z-axis vector for the position. Then we need to set the look at of the C-frame to the 0 vector. This will make the C-frame face the origin, which is where the model is. Set the current camera of the viewport frame to the camera. Finally, parent the camera and model to the viewport frame. Now we need a function that will update a slot button whenever we call it. This function will receive a slot button and the tool we want to display in it. First, we'll check if a tool has been given. If not, hide the slot button and return. If there is a tool, we can set the tool name label's text to the name of the tool. Then set the texture ID image's image to the texture ID of the tool. We also need to clear the viewport frame in case it has anything inside it. In the case that the tool doesn't have a texture ID, we'll instead set up the viewport frame using the function we just made. Finally, we'll make the slot button visible. Now create a function called createSlotButtonName. It will receive a number corresponding to the position of the slot value in its folder. The function will return the name for a slot button at that position. We need this so we can specify the order. By default, the ordering is done alphabetically, meaning a number like 100 would appear before 2. To get around this, we'll use underscores at the beginning of numbers. Underscores take lower priority, so will show up at the end. Going back to our example of 100 appearing before 2, if we add an underscore before 100, it will now appear after 2. But we'd also need to add underscores for 2-digit numbers, otherwise the number 10 would also appear before 2. This means we need to vary the amount of underscores we put before the number. The more underscores the number has, the further back it appears. To determine how many underscores to add, we can simply look at how many digits the number has. For a 1-digit number, no underscores are needed. For a 2-digit number, a single underscore can be added. For a 3-digit number, 2 underscores can be added, and so on. So first, we'll convert the number to a string. We'll also make a variable for the slot button's name. We only need to add the underscores if the length of the string is greater than 1, meaning it is at least a 2-digit number. Then we can iterate from 1 to the number of digits minus 1. Each iteration will add an underscore to the button name. After that, we'll just add the number to the button name. Finally, we can return the name. The next function is called getKeyName. This will receive the Keybinds and Keybind displays dictionaries from one of the module scripts, as well as the slot number. It will return the text to display on the hotkey text label. First, we'll look in the Keybind displays dictionary. If we can find a mapping, we'll return that. Otherwise, we'll get the list of inputs for that slot number. Since not all slots have inputs associated with them, we need to make sure there are inputs for this key. If so, we'll take the first input key code, we can convert it to a string. From the string, we can split it into a list separated by the dots. The third element will be the name of the key, which we want to return. Now we can finally make the actual slot button. Create a function called createSlotButton that takes the slot value. First, we'll get the slot number, which is just the name of the slot. Then we can create a copy of the slot button template. Set its name to the result of the createSlotButton name function. Now we need to get the text to display for the hotkey label text label. Let's create a variable with an initial value of nil. If the slot value is in the hotbar folder, we'll make the variable equal to the result of the getKeyName function for the hotbar Keybinds module script. Otherwise, we'll use the backpack Keybinds module script. Then we need to check if the Keybind display variable has a value, meaning the function returned something. If so, we'll set the hotkey label's text to it. Otherwise, we'll hide the hotkey label. Call the updateSlotButton function to set up the slot button. Then we'll listen for the destroying event of the slot value, which fires when the object is deleted. If that happens, we want to delete the slot button. We also need to listen for when the value property is changed. If the slot value is in the backpack folder and the new value is empty, we need to delete the slot button. We can also return to exit the function. Otherwise, we'll call the updateSlotButton function with the new value. Finally, we'll need to return the slot button. Now we can create a function to make the hotbar slot buttons. Inside, we'll iterate over each value in the hotbar folder. For each value, we'll call the createSlotButton function. Then we'll parent the newly created slot button to the slots container frame. Now we can call this function. Let's run the game. We have 4 tools in the hotbar. If we pick up another, it shows up in the 5th slot. If we drop it, the slot becomes hidden again. The flashlight doesn't have a texture ID, so it's using the viewport frame. The viewport frame doesn't show the flashlight properly, so we'll have to adjust the settings. Let's multiply the distance by some amount. Now the entire flashlight is in view, but a different angle would work better. Instead of the z-axis vector, let's use the x-axis vector. I'll also adjust the distance again. Now it looks fine. This is something that will be difficult to make consistent for every tool, so I'd recommend just setting a texture ID for all your tools. We also need a function to create the backpack slot buttons. Iterate over all the values in the backpack folder as we did for the hotbar folder. This time we'll get the name of the slot button for that slot number. Then we'll search the backpack scroller for a slot button with that name. If it doesn't exist, we'll create a new slot button. Let's call this function. We also want to call this function on the child added event of the backpack folder. When this event fires, it means a new backpack value has been made. Let's test the game. Initially, we don't have anything in the backpack. As we pick up tools, the backpack should fill up. Let's also make sure the slot buttons are being deleted when we drop backpack tools. Now we need to handle equipping and unequipping tools. The script needs to keep track of which slot button is displaying the equipped tool and which slot value references the equipped tool. So we'll create variables at the top for those two things. This will initially be null, meaning no tool is equipped. Create a function called setSlotButtonEquipped that takes the slot button and changes its appearance to show the tool isn't equipped. Inside, we'll simply set the background color of the tool to a gray color. Make another function called setSlotButtonEquipped that will change the slot button's appearance to show that the tool is equipped. Inside, we'll make the background color white. Now make a function called setUnequipped, which will make the appearance of the currently equipped slot button to unequipped. First, we'll check if there is currently an equipped slot button. If not, we can just return. Then we'll call setSlotButtonUnequipped on the equipped slot button. Finally, we'll reset the currently equipped variables back to null. Make a function called setEquipped that takes a slot value and will make the corresponding slot button equipped. First, we'll call setUnequipped in case something else is equipped. Then we can make currently equipped slot equal to the slot parameter. Now we need to find the corresponding slot button. We'll first get the name of the slot button. Then we need to check where the slot value is. If it's in the backpack folder, we'll look inside the backpack scroller. We need to use wait4child as the slot button might not be created yet since we're making backpack values dynamically. If it's in the hotbar folder, we'll look inside the slots container frame. Finally, we'll call setSlotButtonEquipped to change the equipped button's appearance. Make a function called EquipUnequippedTool that will take a slot value. It will decide whether to equip or unequip the tool. First, we'll check if it's equal to the currently equipped slot. If so, we need to unequip it by calling setUnequipped. Then we can fire the Unequip tool remote event. Otherwise, we need to make sure that the slot has a value. If it doesn't, we shouldn't be able to equip it. Call setEquipped, giving the slot value. Then fire the Equip tool remote event, giving the slot's value. Head over to the Create Slot Button function. When we create a slot button, we also need to call setSlotButtonUnequipped on it because the tool isn't equipped. We also need to listen to the mouse button one click event of the slot button. When it fires, we can call EquipUnequippedTool, passing the slot value to it. Let's test the game. Click on any of the slots and it should become equipped. If we pick up a tool, you'll notice that the one we just had equipped still has a white background. This is because we're only considering when a player equips a tool from the GUI. They can also equip a tool by picking it up from the ground. First, we'll need a function to find a slot value from a tool. Inside, we'll iterate over the hotbar folder's values. If we find a match, we'll return that value. Then do the same for the backpack folder. Now create a function called UpdateEquippedTool. This will make sure the equipped slot button matches the equipped tool. First, we'll look for a tool object inside the character. If there isn't one, the player has no equipped tool, so we can call setUnequipped. otherwise we'll find the slot value for that tool. If that slot value is already the equipped slot value, we don't need to do anything, so just return. If not, call setEquipped for that slot. Now we need to bind this function to the character's child added event. Do the same for the child removed event. Now when we pick up a tool, everything works fine. But it seems I forgot to make the viewport frame's background invisible, so let's do that. Now everything should work fine. Create a function called bindKeybinds that receives a Keybinds dictionary from one of the module scripts, the inventory folder to handle the inputs for, and a prefix for the action name. The reason we need a prefix is so we can have unique action names between the hotbar and backpack folders. Iterate over the keybind pairs. Each iteration will make a local function to handle equipping that specific slot. It will receive 3 parameters from the context action service. Like we did earlier, we need to make sure the input state is begin. Now we need to search for a value with that slot number inside the inventory folder provided. We need to check 2 conditions. If the slot value wasn't found, it means the slot value hasn't been created yet. This will be the case for values in the backpack. If the slot value is empty, it means there isn't a tool associated with that value. For both of these conditions, we can fire the Unequip tool remote event. This means that the player will unequip whatever tool they have if they try to press the key for a tool that doesn't exist or doesn't have a value. We can then return. You can decide to do nothing instead, so you'd only have to return rather than firing the remote event. Now we'll form the action name for this keybind, which is simply the prefix combined with the slot number. Finally, we'll use bind action. Now we can call the bindKeybinds function for both the hotbar keybinds and backpack keybinds. Make sure the action name prefixes are different, otherwise the hotbar keybinds will be overridden. Let's test the game. Everything's working, so we can move on to the next stage, which is handling dragging the slot buttons around. Inside the starter GUIs folder, create another screen GUI. Name it Dragging GUI. This will contain the button the player is dragging. The way we'll handle dragging is by creating a fake of the original slot button. Once we've made the fake, we'll also want to hide the original button to give the impression that the player is moving the original button. We need a way to differentiate between dragging and simply clicking the button. We'll do this by defining a threshold. If the mouse moves a distance greater than the threshold the player is trying to drag, so we can create the fake. We'll need the user input service to get the mouse position and detect when the mouse button is released. We also need the run service so we can constantly update the fake button's position. Let's also get the dragging GUI. Now we need to make some variables to keep track of the elements involved in the dragging. We'll need to store the original button and its fake. We also need to store the value associated with the original button, and we need to store the connection that will update the fake button's position. Then we can define the threshold. I've gone with 5, so the player needs to move their mouse by 5 pixels to start dragging. In the create slot button function, we'll listen for the mouse button 1 down event. This event fires when the player presses down the mouse button, which is how the dragging will start. If the slot value is empty, we'll just return, since the player shouldn't be able to drag an empty slot. Now we'll update the dragging button original and dragging slot variables. We also need the initial mouse position. Now we'll use a while loop that waits for heartbeat every iteration. This means the while loop will iterate every frame, get the new mouse position, then calculate the distance the mouse has moved from its original position. We also need to make sure the dragging hasn't been cancelled, for example if the player lets go of the mouse button. If so, the dragging button original variable will be set to nil again, so we can return. Finally, we'll compare the distance the mouse has travelled to the threshold. If it's greater than the threshold, we'll break out of the loop. After the loop, we can create the fake button, which is a clone of the original. I've also chosen to hide the hotkey label for the fake. To ensure the fake button's size and position are consistent even when the game resolution changes, we need to convert the size and position to scale. To do this, we need the screen size. We also need the absolute size of an original slot button, which is its size in pixels. Then we need the offset between the mouse and slot button. Which we convert to scale. Make a local function called setButtonSize, which will update the fake button's size. Inside, we'll calculate the scale size for the fake button, which is based on the absolute size of the original button. We can call this function as soon as we make the fake to set its size. We also need to make a function to update the position. First, we need the mouse position. For each axis, we'll convert the mouse position to scale. Then subtract the corresponding scale mouse offset. Let's also call this function. Now we can put the fake in the dragging GUI. Hide the original button. And set its appearance to be unequipped. Finally, we'll create the connection. The event we'll use is heartbeat. First, we need to update the screen size in case the player's game resolution has changed. Then we need to update the absolute button size. We'll base it on a slot button in the hotbar. Now we can call the set button size and set button position functions. Let's run the game. We can drag the slot button around. Now we need to handle dropping the button once the mouse button is released. First, we need the GUI service to get the size of the top bar. This is because the top bar will affect the position of the GUI relative to the mouse. We also need a function to set all the dragging values back to nil once the dragging has ended. In the hotbeat connection, we'll check if the fake has been deleted. If so, we'll reset all the dragging values and return. We'll also reset the values when the mouse button one-click event fires. To handle what happens when the player drops a fake button somewhere, we need a function to check if the mouse is inside some GUI element. Create a function called isMouseInside that takes the mouse position and the GUI element we want to check. First, we need the minimum and maximum positions of the GUI element. The mouse position will be outside the element if it is less than the minimum position. The mouse position will also be outside the element if it is greater than the maximum position. Finally, we'll return true as the mouse position is inside. Now we need a function to get the hotbar slot the mouse is over. This function assumes the mouse is over the hotbar container frame, so instead of checking if the mouse is inside each slot, we'll only check the x-axis. If we find the button that the mouse is over, we'll return the button, as well as the slot number so we can find the slot value associated with the button. The next function will get the backpack button that the mouse is over. We'll iterate over each value in the backpack folder and find the associated slot button. Then we can use isMouseInside to check if the mouse is inside that slot button. If it is, return the slot button and the slot value. Create a function called shiftEquippedSlot. This will take a slot value that is empty, and if it belongs to the backpack folder and the equipped value is also in the backpack folder, the equipped slot will be shifted down. In the recording, I forgot to add this line. Make sure you add it or you'll get an error when the player has no tool equipped. Now we need to make sure both the equipped slot and the provided slot are in the backpack folder. Then we need to make sure the equipped slot comes after the provided slot. If these conditions are met, we need to shift the equipped slot down by 1. Now let's write the function for swapping 2 slots. First, we'll fire the swap slots remote event. Now we need to consider the current values in the 2 slots. If the first slot is the equipped tool, then we need to set the second slot as equipped since they will be swapped. And we'll do the opposite if the second slot value is the equipped tool. Now we need to check if the first slot is in the backpack and the second is empty. If so, the first slot is going to be deleted, so we need to call shift_equipped_slot passing the first slot. We'll also do the same for the second slot. Create a function called moveToEndOfBackpack that takes the slot value. First, we need the number of backpack slots. Then we'll fire the moveToEndOfBackpack remote event. If the tool referenced by the slot is parented to the character, meaning it's equipped, we'll need to update the equipped slot. If the slot is in the hotbar, the equipped button will be at the position of the number of existing slots plus 1. If it's in the backpack, moving it to the end won't change the size of the backpack, so the position will be at the number of existing slots. If the tool isn't equipped, but a different tool is equipped, we should call shift_equipped_slot. Make a function called dropTool. It takes a slot which references the tool to drop. First, get the tool and fire the dropTool remote event. Then we can call shift_equipped_slot. Now we'll handle when the player lets go of the mouse button, which should stop the dragging. We'll use the input_ended event of the user input service. First, get the user input type from the input object parameter. Then we need to make sure the input type is either mouse button 1 or touch. Mouse button 1 is the left mouse button and touch is for touchscreen devices. If the dragging button fake variable doesn't contain anything, it means nothing is being dragged right now, so we can just return. Otherwise, we'll terminate the heartbeat connection. Then delete the fake button. We'll get the size of the top bar using the getGUIInset method of the GUI service. Then we need to subtract it from the mouse position. First, we'll check if the mouse is inside the backpack container frame. It can only be considered inside if the backpack is also visible. If so, we'll find which backpack slot the mouse is over. If a backpack slot was found, and if the dragging slot is the same as the found slot, we'll just make the original slot visible again. This is because the player has tried to drag the slot over itself, so we don't need to do anything else. Otherwise, the player is trying to swap 2 slots, so we'll call swap slots. If no backpack slot was found, the player wants to move the slot to the end of the backpack. Next, we need to check if the mouse is inside the hotbar container frame. If so, we'll find which hotbar slot the mouse is over. Since the function only returns the slot number, we need to look up the slot value with that number. Again, if the dragging slot is equal to the hotbar slot, we'll just make the original button visible. Otherwise, the player wants to swap slots. Finally, if the mouse isn't inside any of the inventory UI, they want to drop the tool. At the end, we'll reset the dragging values. Let's test to make sure everything works. When we swap a slot with an equipped slot, we can see an issue. This is just a typo, the slot passed should be slot 1. Let's try that again. If we try to drag a slot on itself, if it's equipped, it becomes unequipped. This is a simple fix. When we check if the dragging slot is equal to the slot that the mouse is over, we also need to check if that slot is equipped. If so, we need to call setEquipped. This is because we call setUnequipped when we start dragging. Now everything will work fine. If this video helped you, make sure you subscribe and like the video. If you have any ideas for future videos, let me know in the comments. You can also join the Discord server to send your ideas. Thanks for watching, and I hope you have a wonderful day.